ready to go?
Are you ready to go?
No, of course, always ready. Okay, so we're BMS. It's Jorge, Jason, Keith, Nima, and Guto, and the product that our company is involved in is a battery management system. So a battery management system. So the problem is related to the car batteries used in electric vehicles, be it hybrid, plug-in hybrid, pure electric, and all the different varieties. The multi-cell lithium-ion batteries that the full electric cars already use and that the hybrids are switching to this year, they're not efficient, certainly not as efficient as they should be. The method of charging means that there's uncharged space left at the top in a lot of the cells because the cells charge unevenly, and as soon as one cell reaches its maximum, all the charges are shut off. Again, at the bottom, when they're discharging, as soon as one cell reaches its minimum, they all shut off, and you're left with unused capacity in some of your cells or uncharged space in some of your cells.
The current solutions, is that really true in the very latest, greatest battery technology?
Yep. So the current solutions that they have out there, they either don't deal with it or they lead to overheating. There are two ways to get overheating. One is through the method of siphoning off excess charge, and the other is through overcharging. Overheating leads to something that they like to call thermal runaway, but which you probably know better as the battery going on fire.
Boom.
As you've seen with laptops and cell phones on a smaller scale, but has also hit a few electric vehicles and has been, behind some of the reticence in picking them up initially. There's a market out there. Last year, 340,000 hybrids sold in the US, and there was a decline in the number sold, but it was significantly less than the overall drop in car sales. So the solution is a battery management system that manages charging to make sure that every cell reaches its maximum capacity, manages discharging to make sure that they all get reduced evenly and that they all reach their minimum capacity at the same time. So you don't have the issue of cutting off discharge before they're all empty or of cutting off charge before they're all full. Side benefit, no overcharging, no overheating, no fires, which is always nice. But it also increases the lifespan of the battery, which in itself is useful in money saving.
The proposed technology offers a state-of-the-art battery management system. This system actively monitors and maintains the state of the individual lithium-ion battery cells within a block, and obviously that's to guarantee the proper charge and discharge cycle for the battery block. So as you see in this figure here, there is a battery block housing several individual battery cells, and the battery management system over there is the device that will be manufactured by us and it will be offered. So to guarantee the proper charge and discharge cycles, the charge and discharge voltages must be maintained within a known restricted areas. So on the figure left here, if the discharge voltage goes below the minimum voltage, the battery, permanent damage would occur to the battery cells. Similarly, on the charge cycle, if the charge voltage goes above the limit, explosion might occur. So this is a graphical representation of how this system works. As we see, we have different battery cells with different capacities. Our system will operate to charge them all equally up to their maximum charge level. And for the discharge, it also discharges them to the equal level of discharge. So the way that our system performs this operation increase the efficiency of the battery pack from 15 to 30%. We have a working prototype up and running in the electrical engineering department in UBC here, and the prototype is ready. And we have industrial sponsors and people who are very interested in electric cars, such as Curtis from PMC Sierra, and he's one of the supporters of this project.
How do you translate 15 to 30% efficiency in money? What is the economic coefficient of that?
Yeah, so the way that this system works is, since it increases the lifespan of the batteries, and since not only the lifespan of the batteries, but also the lifespan of the components, such as relays and all the components in the PCB design. due to the less amount of switching and monitoring.
So, benefits from that?
So,
last buyer of the product? The first buyer care?
Well, one of the issues with the electric cars right now is that they don't have the range. So that's one of the drawbacks to people wanting to buy an electric car. So with this system, if you're going to increase you're going to give another 15 or 30% of range for the car. So it's going to address one of the major problems with
Just lifetime and using the capacity.
Yeah.
I shouldn't have had to ask that question. It should have been, and that's almost the most job, and that's really what you're telling us. And I had to ask you questions to get that.
Yes, Keith said we do have a market that is increasing 18% annually. It's estimated in 2015 that the electric vehicle sales are going to hit 1.5 million worldwide. North American market, it's going to be 560,000 electric vehicle sales, and BMS is going to target that market. The target is going to be electric vehicle manufacturers who want, as we said, increased lifespan and therefore increase the range of their vehicles. Our potential customers are going to be battery manufacturers such as E1 Moly and Cadex, who we already talked to. Also battery management retailers such as EV Parts and local retailers from BC like Canadian Electric Vehicle and Dynasty Electric Vehicle. Yeah, right. We're going to have a strong sales force to achieve higher customer service and explain the benefits of our product directly to our customers. Our competitive advantage is, we said already, increased efficiency. It increases the lifespan of the battery pack and also the range of the vehicle. We achieve this by reducing the wasted energy and energy dissipation. The second competitive advantage will be the reduced, our BMS, or battery management system, is going to enable the battery pack to be charged more quickly, and we do have a competitive price that we're going to explain later. As Nima said, we have a functioning prototype that's been installed in a car that's going to be in the Zero Race, which is a world race for electric vehicles. We also intend to put our product in the Vancouver International Auto Show. We're going to become members of associations of electric vehicles, and we're going to organize local events to promote our product locally.
Talking about our business model, how and where we're going to produce our products. We're going to outsource our manufacturing in Canada for some reasons. We have a better supplier payment conditions when we will be able to pay our suppliers on delivery or even after 30 days before delivery. And if we compare with China, for example, we would have to pay it upfront. Another issue here is the quality assurance, that companies in Canada will be able to provide a better quality assurance for us, and it will make our job, our quality assurance in-house job, easier and less expensive. Another issue is the patent security, which in Canada we can reduce our risk of someone copy our product if we compare with China. And this risk is the risk that we won't like to be exposed to, in order to guarantee our revenues and margins in the next years. And talking about margin, we have this chart that presents value chain, which shows that, as Jorge said before, we have a good competitive price at the end market and still have a great margin for our products.
Okay, so just going through some of the financials, through some of the numbers.
Tell us about the competitive pricing. I mean, I have no idea where your price point is compared to anybody else.
Okay, so there are competitive solutions out there, but there are